All right, let's do this thing. Anybody already get started on it or have a question in a place they want to start at? And we will do that. Number 6. Oh, yeah. And that's graphing ones and remembering what the different things are. Okay, cool. Let's do this. Insert a bunch of pages at the end. Check. Okay. All right, number 6 is the... Anybody remember the name? Starts with an R of what type that is? Starts with an R.
Is it in the question?
What do you mean? Oh, yeah. I didn't see that. Yeah. I've just inserted all these pages and I can't get rid of them. Oh, I'm just going to have to scroll. Hang on. There we go. Sorry about that. 1, 2. All right, so there's 4 different things that you're really, I know I'm not started yet. There's 4 things you're looking for when you see that R word or the rational word. There's 4 things it could be. What are those 4 things? Vertical asymptote, boom. 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 Well, I think intercepts are the same. So there's probably one more thing that you would look for to be able to graph.
In behavior?
Yes. That's the last one. Well, I guess that's horizontal asymptote technically. In behavior and horizontal. Kind of the same thing. So let's get started with, I don't know, which one of those do you... A looks the most like what we're going to be doing, I think. Because I can tell you the one that I've seen, because we looked at it yesterday, has a factor on the top and the bottom. Like, the top factors into 2 normal little things like that, and the bottom factors into 2 little things like that. So if you're looking for ones to practice, that would be the thing that you're really looking for there. So, you said B. B kind of does that, but x plus 2 and x minus 2 doesn't work. I think A's, I guess none of them are really perfect. D, it does look the most like that. Let's do D. Good call. Okay. So we'll take x squared plus x minus 6 over x squared minus 25. And we'll say, okay, well, before, so we'll just do this real slow. We'll go slow today. Before you can do anything, you have to factor. You don't even want to start trying to graph it without factoring. And the reason we picked, this was D, the reason we picked D to do is because it's the only one that looked like you had to factor the top and the bottom, and the test looks the most like that. The other ones are still good practice, but this is just going to look a little bit like factor the top and the bottom. So, step 1, factor the top. You get something like x minus 2, x plus 3, right? That's the factor of the top. And if you factor the bottom, you get something like x minus 5, x plus 5. If you hate factoring, I'm sorry, we have to factor. That goes back to those Algebra 1 days of trying to say what do they have in common. This is all called U of x technically, right? In this problem. All right, so now we can hit up those 4 things that we started with. We said there's 4 things happening. Let's just label them all, and that doesn't matter which one you do first, as long as you're keeping straight which ones they are. So what do you want to do second? Pick anything to do. Don't matter. I heard vertical, then we'll hit that one. Second, we're doing vertical asymptotes. Okay? Vertical asymptotes means the denominator is equal to 0, right? So we got 2 vertical asymptotes, it looks like, don't we? X equals 5, and x equals negative 5. If you don't like going that fast, then you just take each side of it and set it equal to 0 and do your little move over. Plus 5 cancels, plus 5, x equals 5. X plus 5 equals 0. Minus 5 cancels, minus 5. X equals negative 5. There's your 2 vertical asymptotes. Boom, 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 boom. because the denominator equal to 0 gives you your vertical asymptotes. What would those look like? Actually, why don't we go ahead and do that off to the right? If you need paper. Boom. I forgot to say that. Because I know the review does not have enough room. That wasn't the plan. It'd be way too long if we left a bunch of room. So what do those look like? Those probably look like lines going straight up and down at 5 and negative 5. Ooh, this is going to be a three-parter. It's going to have 3 little chunks in it. Negative 5, 5. All right. What were you saying? I think Layla was saying something after that to try.
I was going to say equal it to 0.
Equal it to be what?
0.
Equal the whole thing? Or okay. Yeah, but to save ourselves some time, we can even take it a step easier. What could we equal to be 0? Not the... Technically, it's the whole thing, but it just saves us a little bit of time if we do it with just the top. Because 0 over 1 is equal to 0 over a billion, right? So when you say set it equal to 0, we don't have to worry about the bottom. We only have to worry about the top. So we can take the top and set it equal to 0. And say x minus 2 equals 0 gives you freaking x equals 2. And x plus 3 equals 0 gives you x equals negative 3. And those two things they have a name. Thank you. So here, I'll write that over here. Boop, boop, boop. X-intercepts are set top equal to 0. So then I'm going to hop over to my graph and plot those 2 points. I don't, but I can print one real quick, and then you can go grab it. No, it'll pay for that. You know where my office is?
I don't know.
You don't? Well, here, just go grab it. It's my office. It's right there. Be fast. Wait 1 second. I gotta find it. That's it.
So, and when they ask you these questions, you don't always have to grab one.
Yes. I mean, it might ask you a little sub question, what's the x-intercept? And then you do that first. If this doesn't connect, then you will have to go print it. Why? Wi-Fi sucks. I'll tell you. Oh, you don't. We're going to go back and look at the top thing. That's a good question. Oh, cool. You know where my office is?
Yeah.
You know where the printer is? All right, I just printed it. No, don't do that. So that's at x equals 3. That's probably not where 3 would be, huh? Oh, no, that's x equals 2. That seems about right. And then we need 1 at x equals negative 3, right? Okay. What else? Oh, this is a good one. You just said what about the, what's it called? Yep. What about the horizontal asymptote? How do you find that? Maybe we should have done that first before factoring even. You go up to the very, very top, right? And you look at the leading term and the leading term, and you just rewrite that fraction down below and you see what happens. So I'm going down here to write x squared over x squared. Wait a second, what is x squared? Or what is x squared over x squared? It's 1. So that means your horizontal asymptote is at y equals 1.
On the test, would you always give us the same x?
No, you might have a 0.
So, but like, what if it's like x over x squared?
All right, so x over x squared means bottom bigger. Means x equals 0. Y equals 0. This is side case 1. Side case 2 would be x squared over x, which is top bigger, which is none, or some people write infinity because it goes on forever. The end behavior could be called y approaches. The end behavior could be called as x approaches infinity, y approaches infinity. So that's why they get the infinity. None is referring to, is there a horizontal asymptote? No, there's not a horizontal asymptote. So that's why sometimes it's none or infinity. So we just go draw a line at y equals 1. There's 1. Holy smokes. I think I know what happens in the middle. So that's kind of crazy, though.
Is it going to make a curve going from?
I literally can't imagine what happened.
You can't see what happens in the middle?
No.
How not?
It's a problem.
It's got to be, right?
Yeah.
Little problem.
I mean, it has to hit these 2 points, right?
I
So
don't.
it approaches. It approaches. Yeah, it's got this.
So it's the bottom. Maybe like later or something.
We'll find out in a second. But my guess is going to be something like that.
Yeah.
That's my guess. We'll find out in a second, though. We'll do the system to find out. The system is plug and chug numbers. Is there something else to find, or is that it?
Did you find the Y-intercept?
Yeah, we should find the y-intercept. Good call. What's the y-intercept? Oh, that's the easiest one to do. You just plug a number in, right?
Yeah.
So you get negative. You said if you plug in 0, you get 0 minus 2 times 0 plus 3 over 0 minus 5, 0 plus 5, which is negative 6 over negative 25, which is 6 over 25, which actually isn't 6 over 25, it's 0 comma 6 over 25. Is that bigger than 1? Heck no, it's not. So that's about right there. Boom. Now I definitely know what happens to that thing. Now I definitely know. It goes 0, 0, 0. And I'll tell you, I'm pretty darn sure I know what happens on the other side, but I'm going to plug in numbers to find out.
Can I see your what?
I just plug 0 in everywhere X was. I'm pretty darn sure I know what's happening on the other 2 sides. I'm pretty sure.
Good.
How could you be sure even though we haven't done anything to find out yet? Because they don't cross the x-axis. So I'm pretty darn sure they go like this, right? But you know what we better do just to be safe because we're taking a test and it's important? Plug in a number and see. Plug in negative 6. Plug in. What would you plug in? Positive 6 and see what happens. So after that, to check, I would plug and chug negative 6 and positive 6 just to see. And see if they end up above 1 or not. I bet they do. All right. Let's hit a different question.
Wait, can you?
Yeah. To which part?
To like.
Which step of it?
Step 4.
Horizontal asymptote step? Okay. It's important to note that we got that horizontal asymptote step.
I'm confused what you mean by that. I'm sorry.
No, don't be. Look at these exponents. No, that's actually a good thing to say. Thank you. Bottom exponent is bigger, and top exponent is bigger. That's what we mean by bottom or top bigger. We look at the exponents there, and if they're the same, which happened right here, you just cancel them out and reduce to whatever number it ended up being. That's that horizontal asymptote rule. It doesn't have a name. The rule for horizontal asymptotes doesn't have like a name or something. It's just this random system where you check for those 3. Yeah, for sure. Though I haven't plugged in those points to be honest, so I don't know for sure. Did anybody get 6 plugged in and see what they got for it?
24 over. Well, I did negative 6, and I got positive 24 over.
Oh, that's bigger than 1. Okay, so it's above the horizontal. So we pretty much put it in the right spot. Cool. All right. And I'm recording this, so go back online and I'll try to post it in between classes. And then I'll post second hours if you can't make it. Not second hours, second like whole class as well. So I'll make sure I get those up today. All right. Hit me up with some more. The more we get done, the better for everybody.
Can we do one?
Yes. Oh, yeah.
Complex zero. Can we do everything?
No, we can do as much as we can do in the time we have. I'm trying to remember if one's super important. I don't remember if it was on there. Yeah.
You didn't say. You said the only complex one was grouping one. A grouping one.
But was this on the outline that I gave you? Did you look at the outline? Oh, I thought I did. Hey, we'll come back to one. I'm gonna come back to one in a bit because I'm pretty sure that's not the most important thing on here. It is on the review, but screw it. No, hang on, we're gonna do it quick because it is still math and it applies to everything because it's polynomials. It's just a little more theory-y or like the concepts you use on it are on the test. Is this specific type of problem on the test? I don't know. I can't remember right now, and I'm not going to go pull it up because it's recording this screen, not that screen. So if I were to freeze that screen, just be like, okay. So how many zeros are there?
4.
I think, right?
Yeah.
Oh, that's not how we know.
Oh, see.
How do we know how many zeros there are?
The degree?
Yeah. To the degree of 4. That means the highest exponent ever is 4. Degree is your highest exponent possible. Okay, so what are your zeros? You have a 0 of 4. So that's x plus or minus 4. Minus. And if you don't like it, go ahead. Once you write it, plug it back in, see if it gives you a 0. That's why it's called a 0.
Wait.
This is 0 is a 4.
Oh.
With the multiplicity of 2, what does that mean?
Squared.
Boom. And 3i, x minus 3i. Wait a second. What's the degree that we have so far?
4.
No, I'm looking at a degree of 3 right now. What's the other freaking thing? Because it doesn't give it to us.
Maybe x plus 3.
It has to, not could. It has to be x plus 3i. That came from that rule that said, I don't know, not that
Plus or minus.
it has to have the other one, right?
Yeah.
The complex conjugate. The other one, plus or minus sign. And why? Because that sign can only come from the quadratic formula. The I has to mean square root, right?
Oh, and x plus.
The only square root ever existing is the quadratic formula, plus or minus. And then you're saying, well, what about 0? What if it's 0? Then they're the same? Well, if it's 0, it's not an I because that's an allowed square root. So that can only come from a negative number underneath here, right? That means this plus or minus is happening. That means they both existed. There's no other situation where any polynomial gives you an I. It has to be a square root, which means it has to be plus or minus, which means it has to have both plus and minus. I don't, but I can print it. You want me to print it in my office real quick? You can run and grab it. Go. No, where are you going? Go get it. I'm not gonna go get it for you. You know where my office is?
No, actually, I've never been here.
Well, never mind. I was gonna say something mean, but it's being recorded. Also, it wouldn't be true. I just opened that. There it is. All right, go grab it.
Where is it?
Like where this room is, but on that side. And my name's on the outside of the door. My name's on the outside door. If you just start walking around this building, look at all the doors, my name's on one of them. And it's on the printer in that hallway. I know. You got it. I believe in you. Don't go too far. It's literally like where this store is, but on the other side of the building. And my name's on the door. It's next to the stairwell. It's to the left of the big glass building office thing. Okay, wait, we're not done. Because we found the polynomial, but we don't know about this coefficient. This coefficient for the x squared. Well, we don't have an x squared term yet. We have to do the actual mathy stuff. We have to do the FOIL. We have to do the x minus 4 times x minus 4, which gets you x squared minus 8x plus 16. Right? And we have to do this FOIL, which is probably x squared plus 3ix minus 3ix. They're going to cancel out. Minus 9i squared. Right? Wait a second. 9i squared is something important. That comes from the definition of what I is.
1?
Very freaking really close.
-1?
Yep. I squared is always, always, always -1 every time. So that technically is just x squared plus 9. Oh, crap. We have to do it again. We have to do our FOIL again. So what's x squared times x squared? The way I do this when you have way too much to FOIL is I just do like a careful rainbow. X squared times x squared is? Watch, you'll see. X squared times 9 is? Okay, I'm going to change colors. Done with x. I'm done with that one. I'll do blue one now. -8x times x squared is? -8x cubed. -8x times 9 is? -72x. Okay, I'm done with the blue one. Green one. 16 times x squared is 16x squared. 16. Holy crap. Someone help me out with that. 16 times 9. 10 times 9 is 900 plus 50. What? Really? I trust you. 16 times 9?
That's right.
Cool. All right. Any of those get combined together? Mm-hmm.
Why do you circle the I squared?
Because I squared is -1. That's just that what comes from the first day of it, learning the definition of what I is. The definition of I is technically I is the square root of -1. Square both sides, you get that rule.
So if it's squared, it cancels out the square.
Yeah. And it leaves it on the other side, cancels it out, and now you got that rule. What combines? Someone said it already. The x4s alone. The x3s alone. The x2s combined to get plus 25x cubed squared. Minus 72x plus 144. But hold on. The thing said the coefficient was supposed to be what? Negative. So what do we do to the whole dang thing? Times it by -1. And you're done. Got your polynomial. Would that still have all the same zeros? Yeah, because you just reduce it and the -1 stays out to the side, right? The red circle up at the top right now. See where it says the coefficient for x squared better be -25?
Oh, so that.
But it was positive 25.
So that last part is telling us.
Mm-hmm.
It's not actually a part of.
No.
Okay, see, yeah, that's why I was confused. Can we just maybe go in order and skip 6? No, because I genuinely looked through all these problems and need help, so I'm not even going to pretend like.
Which one? 6?
No, I was saying since we just did, y'all just did 6D, right? So I was saying, could we just like.
No, because I got it. Yes, but see if anybody has any important ones.
Oh, okay.
Because we won't get through it if we do that. All right.
13.
Yeah. 13 looks like a laws of logs. Oh, nice. And this is expansion, probably.
Wait.
You said 13 or 14?
13.
Oh.
13. She said 14.
13's pretty sweet. This might be my favorite. What?
Wait, so at the end of the problem, if you set the coefficient supposed to be, that it was -25.
If it would have said -50, we probably would have multiplied by -2.
Oh, it was the answer came out positive. Okay,
Yep.
I haven't finished foiling. Sorry, that foil's slow.
All right. What are we looking at? We are looking at some logs. And this is straight up properties of logs. Do you know? What does 10 and the log do to each other? Boom. Every time. You're left with? Done. Don't make it harder than it has to be. What does L and an E do to each other? Boom. What are you left with? Done. Let's do the reverse of those two just because maybe you'll see it. The reverse of those two situations would have been actually, what do you think? Whoa. What do you think the reverse of those two situations would have been? Log of 10 to the 36. It's not the exact same problem, but it's like the reverse type of property. What happens to that one? Cancels. You're left with 36, right? That's just a thought experiment to see like, oh, I can see it both ways. What's the reverse of that one? E to the power of ln of? We can just say 3 since it's working that problem. Different problem, but I just want to show that like, oh, e to the ln cancels, you're left with 3. 10 cancels log, e cancels ln. Whether it's no matter which one's the base and which one's the exponent, that's just what happens. Ooh, scary. What do we do here? 3 to the third is 27, right? So maybe we can. Well, I'm just taking the good first step you just said. I'm not rushing it. We're going to get there. Taking the good first step. You said 3 to the third is 27?
Yeah.
So I wrote it. Don't try to do a million things.
But wouldn't that be the square root would be divided by 2, divided 4 by 2?
So technically, wouldn't this be 3 to the third to the 1/2?
Yeah.
Now you have 2 options. You can move it to the front, or you can combine the exponents by multiplying them. So let's combine the exponents by multiplying them first. Log 3 of 3 to the 3/2. Right?
Yeah.
So what does that leave you with? Same thing we just did above in blue. Cancels and leaves you with 3/2. Okay, but watch this other step. What did you say the other thing was you could do once you see that exponent happening? Take the 1/2 and it goes out front, right? From that rule. That leaves us with 1/2 log 3 of 3 to the third. What happens there? We're left with? You're left with 1/2 times 3, which is? Hey. It doesn't matter which one you do, whichever one you like better. You're allowed to do both rules.
I think I missed the day where we went over
Oh no! Go look at it. And...
I understand like the basic concepts of logarithms from like algebra 2. It's just rewriting them.
Look and see. Logs would have been like 3 days, right? Didn't we do logs for 3 days? Because we did log properties, log equations.
Was it like
Maybe just 2 days.
Was it like the week before?
I don't remember. I'm sorry. I know we did exponent, and then only 2 days of logs.
Is it like what do you know what unit it is? Like 4.0?
I don't remember.
It's 4.7.
Yeah.
Thank you.
Yeah, because I have 4.1 and then I just skipped to 5.1.
It was immediately after exponents. We did 3 days of exponents. Immediately after that.
Yeah.
All right. What else? Hey, let's crank through all these.
You just subtract them, right? No.
Subtraction on the outside turns to division on the inside. Only if they have the same. Yeah, you can't. I don't want to say that rule forever because what if they try to trick you or something? I'm not going to, but sometime in the future they may try to trick you and you'll see 2 logs and you want to subtract them, but they don't have the same base. So that turns into log 2 of 80 over 10. Wait, now I'm scared. Is that the rule?
Yeah, it is.
Okay. I don't know why my brain's not liking that right now. So that's log 2 of 8. I definitely know 8's a thing. And remember, if you don't remember what the thing is, or you can't see what to do, always just start with that base, because that's what you want to cancel, right? What's 2 to the 1? 2 to the 2.
4.
2 to the 3.
8.
Ah, there we go. So 2 to the 3. Cancels, you're left with? No. No, if the answer's 3, you got to get down to that answer. Now, if the answer's like 6.2 far, then we're not going to do that. Like if the answer's like log 2 of 7, leave it. But if it's log 2 of 4, you better, by golly, do it. Log 8 of 4, was this the one we were doing the other day that was hard?
Yes.
Yes. And I tried to do it at home. I was thinking about it. There's no easier, or I'll try to think of an easier way to explain it. Let's do f first real quick because it's easier.
Would we get calculated?
Log 6 of, what's 4 times 9?
36.
So log 6 of 36. Is there a better way to write that?
Log
6 squared.
What happens to those 6s? 2? Okay.
So if like log base 6 has like 6 in parentheses, just cancel it.
Yep. As soon as you see the base, as soon as you ever see the base, go ahead and start trying to think, can I write that in terms of the base? That's what your brain should be doing. You shouldn't be trying to just figure.
What is the proper term for like that? Like the numbers in the like log base.
The argument.
Argument.
The argument. You want the argument to have a base that's the same as the base of the log. Is if you want the word. You want the argument, which is this, to have a base, which is this, that matches the base of the log.
And then the exponent's just like.
And then the exponent's the leftover answer.
Wait, why'd you skip over E?
Because it's a little bit harder, and I saw how easy F was, so I wanted to do it, and then we'll do this slightly harder. E1. Log 8, 4.
Slightly harder.
Well, the reason is because what I just told. What's 8? Is that if we're looking for 8 to be our base, it's a little bit harder to see what 8 turns into for 4. It's definitely going to be a fraction, right? Mm-hmm. So we want it to look like log 8, 8, something.
Whatever it's.
We got to start messing around with it. What's 8 to the 1/2?
8 to the 1/2. That's basically root of 8.
That's basically root of 8. Do we know it? Then it's not going to be on this part of the test.
Okay, good.
Right.
So it's maybe a 4.
1/3.
2.
Maybe a 4.
Oh, crap. That's too small. We got to try something in between those two things. 2/3. What's 8 to the 2/3?
How are you even supposed to find?
You square it. You go in a circle.
You square, then you cube root it?
Yep. You square it, and it turns into 64. And then you cube root it, and it turns into
4 times 4 is 4. Okay.
That's way too much. We not gonna have that type of question in that test on Python.
what? Yeah.
If it's calculated, I have it.
That's pretty normal. It's a pretty normal question right there.
Wait, why'd you put 4 in the square?
Wait,
It's not 1/4
It should be
because it's
2/3.
smaller.
Oh my gosh. Oh my
It's
gosh.
smaller.
Wait.
Mhm.
Thank you for catching that.
No problem.
I wasn't talking to you.
Oh, hell.
Yeah, was it?
Alright, left to there, buddy.
Yeah.
That was
All right. What are we doing here?
9G. B.
Let me take a picture of it real quick.
Okay. I'm recording it as well.
Okay. I just took copy of it right now because I don't want to do it later.
That's at least you're honest. 9?
A and B.
9B. Sketch each graph. Oh, I love these.
Yeah, please do B.
No, these are it's gonna be all right. It's not gonna be bad. For these, the main goal, it says sketch each graph and state its domain and range. What all does it say? Because I didn't read it.
Yes.
And asymptote, show the x and the y intercepts. Blah blah blah. All right. Paste. So we got to sketch its graph. The way to sketch its graph is just to pick the numbers that you think are going to work out nice and easy.
Wait, which question is that?
We're just going to pick some numbers that we think are going to work out nice and easy. Let's pick a number and put it in a table. What number looks good? 0? So if x is 0, what does that make g of x? 0 plus 3 is 3. Log 3 of 3 is 1.
Wait, what?
Okay. Let's go hop over here and plot that point. 0, 1.
You know what? I'm gonna do it.
What else we got? What is it? What might be another easy point? I don't think 1's going to be pretty, right? 3? Because that turns into 6.
Oh no.
No, but I know what you're going to say next.
6.
6.
Yeah.
Because 6 plus 3 is 9. 9 is 3 squared. So that's 2.
It's a big jump.
Wait a second, y'all. I think I know what the next big jump is going to be.
No.
Isn't there like transformation?
Oh yeah, is 9 gonna be 3?
Is 9 going to be 3? 9 plus 3 is 12. No, we got to get to the next one. 27.
Wait.
24.
4 plus 3.
Oh, 24. You're right. Yeah. So 24 is 3. All right. So we've got 0, 1, 6, 2, 24, 3. So it's kind of looking like this, right?
Yeah.
We need some of those left numbers now.
Yeah.
Yeah, that's okay. They're not going to be bad.
Complete opposite.
-6? Yeah.
You want to try -6? That would give us a -3. What's the log of -3?
That's wrong.
We don't have the negative logs, right?
We don't have log of 0 nor.
Dang, that was too far.
Wait, so do we just leave it like that?
We got to figure out what happens on the left side.
So there's an X-Intercept.
We got to figure out what happens on the left side. It might help if we remember the graph of log.
Can we just sketch it?
We can sketch it, but we need to know something. We need to know what the graph of log looked like. And we also probably want to know at least like 1 point or so, right?
Can we try -3?
-3 would give us a 0. Is there a log of 0? But we just got to something. If you try -3, you get -3 plus 3 is 0.
Right.
What's the log of 0?
1.
No, that's log of 1.
Undefined.
Not undefined. It's the first error you get. It's undefined, and it's actually, because that's the first error you're allowed to get, that's got a name. That is our,
Asymptote.
and now this graph makes a lot more sense. I know what's about to happen here. It's about to go zoom. Remember doing that graph? That's what the log looked like. The exponential graph looked like this. That was EX. And the log graph looked like this. That was ln of x.
Only to look at something like this.
Identifying the x-intercept. Let's find the x-intercept real quick. So we know our vertical asymptote is x equals 3. We know our y-intercept is 0, 1. We need to find an x-intercept. How do we find that? No, that's how you find the y-intercept. But it's like the opposite of that.
Wait, what?
Find the x-intercept.
Isn't that?
How do you find an x-intercept? Set it equal to 0. All right. Now how do we get rid of that log?
Raise it to a power of 3.
Thank you for remembering that. The opposite of log is this thing right here. Right? And what you do to one side? 3 to the 0 is? Thank you for not saying undefined. Anything to the 0 is 1. Log of 0 doesn't exist, right? You gotta be careful with those backwards and forwards. So now we've got x plus 3 equals 1. Oh, shoot. That's actually pretty easy. So x equals? Excuse me. So we've got -2 comma 0. So I drew that kind of bad. I'm going to resketch that, the left side. Everybody's stuffy today. What? What? Is it? I guess it did get hot again. It did get hot again. I just my nose does that when it goes up and down like temperature. Like you walk outside, it's cold out of nowhere. What's wrong?
Oh, I mixed up the points on the graph. I was doing X for Y when it should have been X for X.
All right. What else we got?
Can we do 14?
19 then 14. Oh, shoot. 19 is a little like, I told you just need to memorize the unit circle. And then you look at 19, you're like, that's not on the unit circle. We didn't memorize that point, right?
Yeah.
But we did memorize at the very beginning of ever the formula for the unit circle. Close. Yes, because the radius of the unit circle is 1. That's how you can remember that. 1, 0 is a point on the unit circle, right? That makes the radius is 1 all the way around. 1, 0, 0, 1, 0, negative 1, or, you know. So that pretty much solves the problem for us, doesn't it? Does that formula solve it? Who asked for it?
I hope so.
Well, I mean, it's not going to be easy. I'm just saying, looking at what the problem's given us.
Oh, the 11.
Yeah. That does make it easy. That does make the algebra easy, but it makes the pre-cal done. We're just going to plug that in and solve for y. So square root 11 over 6 squared plus y squared equals 1. So y squared equals 1 minus square root 11 over 6 squared. Anybody got that? 1 minus 11 over root 6. That's so ugly. Wait, what the heck? This is the ugliest problem I've ever seen in my life. Wait, why did I square root it? I was supposed to square it. No, now it's not ugly anymore. 11 over 36. Good. I was like, that didn't make sense. Now I need to do what I just did. Now, how do we get y by itself? Square root that whole dang thing. Actually, wait, let's get a common denominator first so our life doesn't get worse. Yeah, we should just subtract them from each other. 36? What? Oh, for the 1. I thought you were saying for the final thing. Yeah, so what's 36 minus 11? Is it 25? Anybody else get it? Okay, cool. So, oh, look at that. By golly. You see it? Anybody see it yet? You see what's happening here? Y squared equals 25 over 36. Square both sides. Y equals. But wait. There is more. So what's our point? 6 comma 5 over 6. And what does the problem give us that we can't ignore? Quadrant 4, which means plus comma minus. So which one of those gets to be minus? The one we just found. I'll zoom out.
The thing with the whether just double check our work, I guess.
What? No, it's to make sure we know the plus or the minus sign. When we introduce that square root for the first time ever, we have to take into account, is it plus or minus? We don't know. We're just going to power through the break. If you need to use the restroom at any point, just go ahead and do it. We're going to power through to get as many problems as possible done. If you watch this later on YouTube, just freaking go to half speed and then you can watch it slower. I know we're going fast, but that's to get more practice done, not less. Still going? Yep. All right. What? I said 114 or 17 or something.
14.
Which one?
C.
A and A.
Alrighty. We do have to remember all of the rules of logs. There are 3. Actually, we could refresh those real quick.
Yeah.
There's really only 3 rules. It's log of A times B turns into what? Log of A plus log B. And log of A divided by B turns into log of A minus log B.
And it's the same inverse flip.
It's okay. And then log of A to the B turns into B log A, where that B goes out front. Those are the only 3 rules for this entire type of problem.
If you see a plus in bracket, be careful. That's not.
I always say that. If you see a plus inside the brackets, be careful. It's just there to trick you. You're going to want to make it, or I often want to make it to split a plus in the brackets. You can't.
Like, a plus or minus in brackets.
Like log of 3 times, x plus 2. My brain wants to do some stuff. And it might. I could do log of 3 plus log of x plus 2. But then a lot of time, my brain wants to split this up. You can't. Nothing to be done there.
What do you mean by split?
Like we just did. Like we just split.
Oh.
We split this and this away, right? That went over there and that went over there.
So
You can't do anything to this. You're done. That's the lowest form. As I always just say, be careful. The only thing you can do is times, divide, and. All right, we need to rewrite this. And that is so nice. Why is to the power of 1/2 super nice? Indeed, and where does it go? Just take it to the front. And you don't even have to worry about it for the rest of the problem pretty much. We got a 1/2 out front. We got ourselves a log of all this crap. Okay.
this one gonna be wrong because I had to
What'd you say? Square root is the exponent 1/2. Has to be every time. All right, what do you want to split up first? The plus? Nope, you can't. There's the trick. What are we going to split up first? Yeah, I think so. Because it's touching everything, right? And the multiplication doesn't touch the top. Here's a real good thought, though. See that 1/2? That's going to go with everything. So I'm going to put these brackets around here. And we're going to keep those brackets for the whole problem, just knowing there's a 1/2 out front. So we got log of x plus 2 minus log of x to the 4th x squared plus 4. Can we do anything else? Split the multiplication, and it turns into 1/2, big old brackets, log of x plus 2 minus, be so careful with that minus sign. This is saying minus this whole green thing, right? It's not just minus the first term once we split it. It's minus the whole thing. So you either have to put good parentheses around it or distribute your minus sign, or both in steps. I just see oftentimes, I'll show you here. Let's do, it would be log of x to the 4th plus log of x squared plus 4. More often than not, I see this as an answer. And that's not true because you're subtracting this whole thing, not just subtracting the first term. You're subtracting the whole thing. Boom, boom, boom. So distribute the negative. So we got 1/2, big old parenthesis, log x plus 2 minus log x4 minus log x squared plus 4. Close the big old parenthesis. Can you move the 4 to the front? Yep. Sorry, I was looking for the 4. It's like,
Looks like
That
a
4?
9, yeah.
can that 4 go there? Is there any reason why it couldn't go there? Nope. Good catch, or good thought. 1/2 log x plus 2 minus 4 log x minus log x squared plus 4. Does that x squared plus 4 reduce? X plus 2, x minus 2? No, that would be minus 4. Nope, it's chilling. We can't. It'd have to be the whole thing squared, not just one part of it squared. I want to. My brain wants to do it, but it can't unless the whole thing is squared. The whole argument.
So that's the answer.
What do you mean by that?
Well, you know, it's squared 4 and both of them are squared.
Right. But x squared plus 4 is not x plus 2 times x plus 2. You know that. If it were that, then that's x plus 2 squared, and you can pull the 2 out. But it's not. It's actually like, I don't even know what it is. Is it with an I in there, 2i? X plus 2i, x plus 2i? No, because that would just be 4i in the middle. Oh, it's just not squared. It's oh yeah. You could quadratic formula it to see what the roots would actually be. Heck, if you really wanted to find those roots. What's the quadratic formula of that? X squared plus 4 negative 0 plus or minus the square root.
Don't you have to add an x?
What?
Like a 1 or a 0?
That's what that 0 is. So
What is y again?
I don't know. Just
Just finding the roots of x.
oh, what's 2i? Huh. Look at that. Plus or minus 2i. Those are your roots of x squared plus 4. So not a squared term because it's 2 different factors. All right, what do we got next? I feel you.
Can we do? Oh, can we do 20?
Oh, I love 20. Yeah.
I missed this lesson that day. I went back and looked at my notes and no.
All right, 20. 20 is basically just triangle making. It's can we make whatever triangle exists in the space? I think. Could be wrong, but I think that's all it is. The point P in the figure at the left has a y. Ah, crap. Wait, what was that figure? Just a unit circle?
Yes, sir.
Okay. The point B in the figure has a y coordinate of 4 over 5. Determine the following. So y coordinate of 4/5 on the unit circle. Where is y 4/5?
Can we do the x squared?
Yeah, I think that's all we could do. But before we do that, I want to kind of put a point where y is 4/5. It doesn't have to be perfect, but I kind of want to just put a point so I know what I'm looking at. Actually, does it give you the picture? Or does it not?
It's in part 1. No.
No, it's up there. It's right there. There's the picture. So I don't even have to do this. It's right there.
Oh, well, I mean, I guess.
Right?
It counts. That's for the other problem. Yeah, it's the same.
No, it says consider the unit circle for the next set of questions.
Oh, yeah, you're right.
I'm just being mean. Sorry. Okay, so it's up there to the left, kind of. That's how.
But you have to circle set though. Like, that's a circle set.
Wait, how is
What?
it over here? It's less than
The y. The y value is 4/5. What is the y value at the top?
0.
No. What's the y value at the top? 1. So it
That's
does.
not the point.
Fourth is less
Wait.
than 1. Oh.
Yeah.
What's this dot?
That's about where it is. That's from that picture up there. Fine. Do you want me to go copy the picture? I will. I just was redrawing it because I don't want to copy and paste it.
Oh, they give us the. I thought that E is one number 19.
Consider
Yeah,
the unit
no, the
circle for the
circle
next set of questions.
Yeah. Where it, okay, now it's a box. Yeah.
Where's the paster? Paste. Good golly. Okay. So we know that the y coordinate is 4/5. Holy smokes! I think we already know the answer to the first one. Yeah. What does sine kind of sound like? Y. So it's just 4/5. That's lovely. What does cosine kind of sound like? Yeah, it doesn't.
Okay.
So how are we going to solve for x? Yeah, I think so. 4/5 squared plus x squared equals 1. So you got x squared equals 1 minus 16 over 25. X squared equals 9 over 25. X equals 3 over 5. Almost like it's a 3, 4, 5 triangle.
This is crazy.
What? It's not.
And this is just close.
Is-
Oh yeah, because X.
X cosine. So we got. But wait a second. I think we need a sign. It has to be negative because it's on the left side over here, right? So whenever we hit that square root right there, our brains, or it wasn't right there, it was right here.
What did you do with the 1?
What did I do with the 1? I subtracted 16 from it to get 9. 25 minus 16 is 9.
Yes.
Yes. So I just skipped that little step of 25 over 25 is what I did.
Okay, so what about 10? No, what's the
Okay, so we got 4/5. 10's actually easier than that. If you can get to your cosine, you know how you find tan? Remember the rule? Yep. S over C. Remember when we did that grid of 6? S over C. So it's just going to be 4/5 all over negative 3/5.
Oh, so in order to find tan first, you have to find
Yeah.
the sign and code.
So we're
Okay.
definitely gonna be on the calculator section.
No,
What?
that is a very easy problem.
Easy to.
What do you do at the top? Keep. Change.
Flip.
Flip. 4/5 times with the negative sign, right?
Yeah.
Now something cancels there.
-1 on top.
That's the answer?
Yes, keep, change, flip.
Like, he's in out.
Wait.
Okay, hang on. I'll find the other one like this. Secant is the flip flop of what?
10? I don't know.
Secant goes with cosine.
We're supposed to memorize it?
Yeah.
I think we missed this one.
Oh, you just flip it.
Okay, I'm gonna go find another one then.
What is
Yeah.
it?
Shh. Hey, chill, y'all. What's up? I didn't cancel the negative. Nope. If you want to see the math behind that step in my brain that I did, because I know what question you're asking.
I know what it was. I very well.
This is the actual math happening in the background of what you're asking, right there, and now you can see it stay. Yeah.
What do you mean by
Change division sign to multiplication. That's why I always put that dot in the middle there. I'm changing that big old division sign to multiplication, and then I'm flipping the bottom fraction. Okay, hang on. We're not moving on from this. I'm gonna find
Wait, where do you get a negative? Why is it always plus or minus? Darn it.
hang on. Here we go. This is what we're gonna do.
The reason why we chose
1 over
Negative for
Negative 3/5.
yeah, his question.
because we chose the addition.
What?
Oh yeah, X is negative.
Find all 6 for t equals pi over 6. That's the first one in the unit circle. Find all 6 things. Oh no. No, it's magnetic and it dropped. And it's stuck on the side of the desk. Find all 6 for those. I can't even write it. I have to move this to right.
Like draw the bicycle?
No. Find all 6 things. Sine, cosine, tangent, secant, cosecant, cotangent.
Okay. Period.
I don't remember that one.
This is just something.
Yeah, no, I just wrote it because that last one was so messy. Find all 6 for that. If you want the word, they're technically called trigonometric functions. Take a second. Breathe. I know you're like, whoa, where'd you get that? Where'd you get that? Where'd you get that? Find all 6 things for pi over 6. The sine of pi over 6 is 1/2. The cosine of pi over 6 is. The tangent of pi over 6 is. Times. Oh, no, you're right. Sorry. I was just going to go ahead and flip it in my brain. 1/2 over root 3 over 2. Keep the top. Change division to multiplication. Flip the bottom. Cross out the 2. You're left with 1 over root 3, which is the same thing as root 3 over 3. And then what do you do next to them?
So what happened is we put 1 over 3 in the answer.
If it's worth 10, you get 9 of them. If the problem's worth 10, I'm not going to say you didn't know the math. You knew the math. But the step behind that is this right here. If you multiply 1 over root 3 by root 3 over root 3, which is just multiplying by 1, you're allowed to do that. The top turns into that, right? And the bottom turns into that. That's where it comes from. It's called radicalizing the denominator. I don't actually know why it's essential, but the pre-calc for calculus next year, I've learned. Last year I was like, I don't care. This year for calculus next year, I think it's important to. And it's also important for multiple choice stuff if you ever get in that situation. So what do you do with all those now? Cosecant, secant, and cotangent. And you don't have to do any math for these guys. You know what you do? You just flip them. I lied. Now that I see the 3 on the bottom, we do have to do a little bit of math. This would equal 6. No, that's not true. 2 root 3 over 3. And this would equal just root 3.
Whenever you do the first sign in cosine, how do you get 1/2 out of the sine pi over 6?
How did I get that?
How do you do
She said it.
sine
Chelsea's.
is the y.
How did you get it?
I just memorized it.
That's the answer to that.
Oh,
Wait,
that's the
wait,
unit
wait.
circle.
Mhm.
Quick question.
So don't even memorize it. Memorize the first three and then draw it good. Like figure out a way that works for you to draw the pattern.
Quick tangent. I heard you said something that we just leave at root 3. Where do we get that from?
I took 3 over root 3.
Oh, I see.
I multiplied by root 3 over root 3. Oh, shoot. Did I mess up?
Basically 1.
No, it's not. That's right. No, it's not basically 1. It's 3 times root 3 over 3, which is root 3. That's where I got it.
So cosine would be what's in that x coordinate.
Yes. Because cosine goes to the x, sine goes to y every time. And then the rest of the other four come from knowing how to manipulate those.
So secant, how do you get 2 over 3? Can you do secant?
Yeah. Just multiply by the denominator as a 1. 2 over root 3 times root 3 over root 3 is, do the top, 2 times root 3.
What? Where you got 2?
Right there.
Yeah.
I just flipped this one.
Oh, so you secant is flipped.
Yes. These are all flipped of the others. All 3 of those are flipped of the one they're next to. They're all the reciprocal of the thing before them. But you do have to remember that cosecant doesn't go with cosine.
Yeah.
Even though I wish it did. You have to remember cosecant goes with sine, and secant goes with cosine. That's where, okay, that's what your question was, is
Yeah,
how'd you get
I
that?
was
No, you
confused.
just flip them all.
Is that like the reciprocal identity?
Yeah.
That's
Well, it's not identities, it's just that's the definition of secant is 1 over sine.
Under the tan is where you get the math for that.
I think so. For the keep change flip?
Change flip.
Yeah.
Mhm.
That math is called radicalizing a denominator.
Memorized.
I know. I told you that. I said it's not like one funnel of one system linear thing of like we need to do all this. It's like 6 different random things that aren't too deep, but they're just deep enough. They're like, ah, crap, I forgot.
like
Mm-hmm.
compound interest. Are you gonna just the formula?
Yes, you always have the formula. You just won't have what each thing is.
Can you do 18?
Sure. I will give you the formulas, but I will not tell you like principal stands for what you start with. You kind of have to remember that. And I won't tell you rate stands for R in the formula.
There's like 2 formulas that we use. I don't know what the difference is.
Oh, I didn't give you the formula in the review, but that's because studying. But I will give it to you anytime you have it on the test. Okay, suppose that $12,000 is saved. That's it. That's called principal, P. Rate called R equals 0.056. That's all they gave us. Oh, they gave us one more thing.
Time 3 years.
Oh, you're right, that too. But per year says compounded yearly. All right, so write the formula for the amount of the account if it's compounded monthly. Excuse me. Oh, crap. So we have to remember that formula. It was A of T equals P1 plus R over N in T. Was it R in T? Like I said, you'll get the formula, but you won't get what it stands for. So it's up to you to know that P is principal. So that's a $12,000 plug-in, right? 1 plus R is 0.056. N stands for what?
Of times is compound.
Compounded times. So if you want to remember a thing that goes within its number. Not year. Year goes with time. Number goes with N. So how many times is this compounded every year? Yep. Because it's monthly. That comes from, where did it say that? Monthly, N equals 12. Daily, N equals 365.
Would the N outside would be 12 times 3.
12 times. Well, we know for the first one, you just leave t alone. Because what does the first one say?
Just find the formula.
Find the formula. And then the second one, you actually probably have to do it, which would be on the calculator section if you had to do it. Find the amount if it's compounded daily. Woof. So 12 thou 1 plus 0.056 over 365 times 365 times what's your t? 3. Yeah, that would be calculator.
Will that be your calculator part?
Yeah, definitely. 1,000,000%. Anybody remember the continuous formula? PERT, I think. Continuously means it every second of every day, every millisecond, it's always growing.
So we use the A, B,
A equals, well, I'll give it to you, but pretty sure it looks like that.
and then for the first one, it's like when there's a certain.
When, yeah, it's basically like at some point the bank's going to tell you your money, you owe me a little more interest. This is if they tell you that a bajillion times in your life. Every second of every day they say, hey, you owe me a little bit. It'd be like, what would it be like? I don't know. Yeah, I don't know how to explain it. Well, if you give me $12 and I say, hey, you owe me 13 in a year. Or I was like, hey, you owe me a cent now, 2 cents now, 3 cents now, 4 cents now, 5 cents now, and keep doing that forever is kind of what the C part is doing. So how long will it take to turn to 20,000? 20,000 equals 12,000 E. What's the rate? 0.056 T. And you just solve for that.
You do like the example.
Yeah. No, well, not yet. The first thing I would do is divide. 12 thou.
Is there a reason
Slash, slash, slash.
Why is 0.056? Isn't it 0.56?
No, you move the decimal twice.
What?
I don't know. It's just what you do.
Isn't it 5.6?
Yeah, but with a percent sign, you move the decimal twice. Percent sign means move decimal twice. Because 0.01 cents is... Wait, that's not good. I don't know. I don't know why, dude. Why do you move the decimal twice?
I mean, 100.
It's out of 100, 100%. If you want 1%, you had to move the decimal twice. True. 1 over 100 is the better answer to that question. 1% out of 100. Oh, you're so right. Per, meaning per. Cent, meaning centennial, or like century. Dang.
That's at the top, please.
That's a good thought. I love, what's that called? Etymology? Yep. It's pretty fun. Latin and all that.
So right now we're trying to find T.
Yeah, so we have find T. So we keep working through this thing. 12 thou cancels out on that side, right? You're left with 10 over 5. Nope. You're left with 5 over 3. What is that?
It's 20 over 12.
Yeah, what is that?
1.66.
Well, it's 5/3? Oh, cool. Divided by 4. Duh. Or 3, I mean. No, divided by 4. E 0.056 T. How do you get rid of that E? L on both sides. You're left with ln of 5/3 equals 0.056 T. How do you get rid of that 0.056? You just divide it. This is how long it would take you to do what it was trying to do. If you type it in a calculator, you'll get it. It will be on the calculator section. Promise, I believe. So. What else we got?
17.
Oh, sweet. I think I just like doing all of them, is what I'm learning. I see a problem, I'm like, that looks fun. Which one?
The last. Well, the last two.
The last two, really. But all right. I think we got to solve some stuff. I think we got to mash together some logs. Let's do D first. How do we mash together those two logs that are highlighted right now? You do indeed multiply. Log 2 of x plus 2 times x minus 1 equals 2.
We're doing 7.
Now what? I think I got to get rid of the log. How do you get rid of the log? You base it by the same number that it has as a base. We get something like x plus 2 times x minus 1 equals 4. Now what? That's not true. I think we need to FOIL. X squared plus x minus 2 equals 4. X squared plus x minus 6 equals 0. X plus 3, x minus 2, x equals negative 3, x equals 2. Factoring. The pre-cal step was the freaking knowing how to get rid of that log. The rest of it was factoring and moving stuff around, combining like terms, all that jazz.
But negative 3 cannot be the answer because of negative.
And then the final step, which I was testing you about, is to check them because why check? Because log. Log is the reason you check. Thank you. If it's normal problem, what's it called? Polynomials, you don't have to check it necessarily. There's not really a log or a square root to get in the way. Log, you have to check it. Thank you. So let's hop back up to the very start and plug in our answers and see what we get. Log 2 of 2 plus 2 plus log 2 of 2 minus 1. It's kind of like log 2 of 4 plus log 2 of 1. Which would be 2 plus 0. That checks out. 2 worked. What about negative 3? Log 2 of negative 3 plus 2. Holy crap, we don't even have to keep going. You can't get negative 1 in there. We're done. We don't even have to solve for the rest and let's see what happens because that is impossible. Those are fun. I think I really like doing log combinations. All right, we got another one?
Log 16.
Got it? Tell me when you got it. 16B.
Yeah.
Round it to 2 decimal places. That's kind of scary. That means it's probably a calculator situation. Or if it's not calculator, you just leave it alone once you're at the simplified thing. You said B, right? Oh, well, it's a dope start. That's actually a really nice start. L on both sides for the start. And you get ln of... Actually, I'm just going to do it up here. ln cancels, and you're left with... Wait. That's not that bad. Get it all onto one side. just not knowing to start with that ln, or not even not knowing, but not seeing to start with that. So then you should get x plus minus 2 minus 1. Thank you. Which gives you x equals 2 and x equals 1. Do we have to check them here? No, we don't have the log stuff. That was a really good brain check to say, hey, wait, we got to check that one. I forgot. So thank you earlier.
Number 15A. I cannot forget.
15A?
Like if they have look easy, but I'm gonna
Ooh. Here, I'll do it up here. Stuff. It does look easy. This is what's tricking you up. How do you get rid of it? Screw. Now we've got log A. Log of A plus log of B squared. Now what? Not division, but log of A B squared. Dunzos.
Can you do B?
Sure. Wait. What?
ln x squared minus 20.
Do we eat it?
I think it's a trick question.
I think it's done.
It is done.
What?
Trick question. Recognize when you have a plus or a minus on the inside, you can't do anything to it.
We can't do anything.
I can't. Can you? I especially can't because of the word combine. Now, if it said expand, I could maybe try to do something, but even then, I don't think so.
Because of the minus?
Yeah. If it were divided inside, we could do something. If it actually looked like this,
Isn't it like X plus 5? X plus 5?
it is, but that we can't. We could plus those two things. But not on this one. It says combine. But if it didn't say combine, yeah, we could probably
That
do.
would be expanding if you do
Yeah, ln of x plus 5, x minus 5. Now we're looking at, this is not the problem. Not what the problem's asking. There won't be tricky ones like this on the test. It'll be very clear what you're supposed to do. I just was grabbing every log I could find and throwing it on the page. X plus 5 plus ln x minus 5, and then you're done for sure. Yes.
Can we fill out a 16C?
Which one? 16C? No? What's going on there? Well, I guess we'll be careful and just go slow. I'm just going to stay up here. Save us time. No, I'm not. That's too long a problem. Change my mind again. Not enough room. Okay, you got an inclination on what to do first? Hopefully it jumps out of the page at you.
Minus
Yeah. What are you going to minus?
the 1.
And now, yeah, that makes your life a little bit better, yeah? Equals just 6. Now, how do we get rid of that 5? This is so important. This should be jump out of the page.
Oh no.
Yes. That's the only way. That's the whole purpose it exists is for this problem.
What did you do wrong?
What did you bring to 6?
What do you mean wrong?
What do you mean but? What is the but?
There we go.
Instead of log of 5, why would you do log of 10?
Well, why would you do 10? Look at what this does for us. That's so nice.
Oh, just kidding. Cancel.
And now we're left with the exponent, right? Oh, crap. We don't know log 5 is 6. But that's okay. You don't need to know it. Now multiply by 10? There's one more way you could write that. That's correct. That's an answer I would take on a test happily. But there's one more way you could write that. Oh, dang it. Okay, there's 2 more ways you could write it. Fine. We could move the 10 to the exponent. I wasn't thinking of that one. Excuse me? What else can you do?
We can do log 10. 3 plus 3.
I gotta sneeze, but I can't.
Can we do that?
Dang it. Me too. Your eyes get all watery. It looks like this. Excuse me. It looks like that.
Oh, it's
Which one goes where? And what goes on the bottom? Yep. Now you can type it in your calculator. Change the base formula. That random formula that says log of A, B equals log of B over log of A. Mm-hmm. It's not to simplify it. It actually makes it look harder. It's not to simplify it. What is the purpose of that?
because some calculators you can't change.
Most calculators you can't. Your iPhone doesn't have a log 5 button. Your iPhone does have a log button and a squared button or an exponential button. That's why that exists. What's up?
My only question is, how come you did log base 5 and then you did 5, 10, x over 10? Like, how did you... Like, whenever you move things around, usually the thing on the equal sign becomes the exponent. I mean, not the exponent, the argument.
11.1.
Like how I did it is I did log base 5, 6 is the argument, and the equal sign, I had the x over 10.
So you just have it backwards?
Yeah, but
You just have that?
yes, that's what I did. It's the same thing. I was looking at the one above it.
No, I know. I'm just listening to you, and you're right. I like what you did. It's the same thing.
But how did you cross out the 5? Look at the thing in red, like above.
Log 5.
Because log 5 I
you
cancel
raise it
out.
to the power.
That's just the shorthand of. This is the shortcut way of writing what you did the long way, or not the long way. You have this just flipped around, right?
Okay. Yeah.
It's the same thing. This is the shorthand way of writing what you did. What you do to one side, you have to do the other side. This is how you cancel out the way you cancel out, like look, this log of A to the X is what?
Is it-
Yep, cancels out. Just the shorthand way of writing it. What you do one side, you have to do the other side.
I just don't understand how you got it from the black part to be able to be canceled out. Because you can't cancel out the part in black.
My brain knew. Oh, how do I get rid of this 5? I log 5 it.
Okay, so you just did that on your own.
Uh-huh.
Oh, okay.
Yeah. And then I said, oh, what I do to one side, I have to do to the other side.
Got it.
And you end up in the same spot that you are because you're right. That's what log means.
Okay.
What you wrote is what log means. It says, what exponent will give me this argument?
And you did how to cancel.
And I just did, hey, we know that log 5 is going to cancel. It's the same thing as if you have x plus 1 equals 4. What do? You minus 1 on both sides, right?
Correct.
But we always do it underneath just because that's the way we've always seen it. Technically, it's not happening underneath. Technically, it's happening right here, right? So that goes away. So it's kind of the same thing. Like we did stuff. We're not doing a different problem. We're doing stuff to this equation.
Okay.
And what you do to this equation on one side, you have to do to this equation on the other side. Same thing here. I just said, oh, doing this is going to be nice. So I'm going to do it because I'm allowed to. But I'm only allowed to if I also do it to the other side. In the same vein, in the same idea, if you have like a 3, nope, that's the same problem. If you have like a log 2 to the x squared equals 4, right? In the same vein, you could do your thing, which is totally cool, by rewriting it. You drop the 2, that becomes your base. That's your new exponent equals x squared. That's what you did really quickly. I don't ever write it like that because I just say, oh, what gets rid of this 2 really quick? putting a 2 up. And what you do to one side, you have to do the other side, 2 up. That's what you wrote already. So no, but you do that though. That's totally cool. I think that's better. That's what's happening in the background. Just like sometimes people might write x plus 1 equals 4, and then like, oh cool, so x equals 3. All they did is not show what you did. All I did is not show the -1 happening. Okay, what's up?
Right.
Sure.
For the calculator, you're probably going to use the change of age formula.
I don't remember, to be fair. Ooh, this one's fun. We can just do this here. We can just do this right here. It's actually not too crazy. No, it's not. Domain. It's got a domain. There's only 3 bad things for domain. You see this word domain? You just check 3 things. First thing. No, that's the whole 3 things. You're right. You're looking for bad spots or bad numbers or undefined locations. What's the first one? 0 on the bottom. Dope. Can this thing ever have a 0 on the bottom?
No.
What?
Yeah.
I think so.
Square root can be negative.
Well, that's
It can have a 0 on the bottom. It just can't equal 0.
how do we find out where the 0 at the bottom would be?
Oh, inequality.
You said it equal to 0, right? Square both sides.
Oh, wow. That's beautiful.
No, that's not beautiful. I don't want to do that.
That part's not beautiful.
I need more room. Hang on. I didn't realize this was going to be a not perfect factor. Yes. Move were you thinking to move them all to the right side? I was thinking the exact same thing. I was just thinking, like, we need to just plus, plus, plus. So we're finding the domain for this guy. So the first thing we're checking is 1 over 0, right? That happens when the square root of 4 minus 2x minus x squared equals 0, which happens when 4 minus 2x minus x squared equals 0, which happens when, if we move those all over, x squared plus 2x minus 4 equals 0, which happens when x minus 2, nope, wait, that looks like it should be good, but it's not. That's so mean of them. That's so mean. Wait, what? That looks like it should be a good one. But it's not. All right, well, here we go. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Wait. Yeah, it does have zeros. They're just ugly. So negative 2 plus or minus the square root of 4 minus 4 times 1 times negative 4 all over 2 times 1. Negative 2 plus or minus the square root of, 4 plus 16, that's 20. All over 2. Negative 2 plus or minus, have I messed up? This is where I always mess up in this freaking quadratic formula. So bad at it. 4 times 5. All over 2, negative 2 plus or minus 2 root 5. Negative b. I was testing you. So it's 2 plus or minus 2. Those 2's are all going to cancel, right? And you're just going to be left with 1 plus or minus root 5 as your roots. I believe, if I didn't make a what? It butterflied out.
You can cancel.
We did not cancel them. They turned into a 1 because if you have a same denominator with different numerators, you can split it up into 2 over 2 plus or minus 2 over 2 root 5. The 2 doesn't just go with one of them. It has to go with both, right? There's your 1 plus or minus root 5. Whoa. So those are your roots. So the domain does not include, x better not be 1 plus or minus root 5.
Wait, hold up.
For that one, because it wasn't a nice neat factor. I really, when I saw that problem the first time, I thought that looks like it should come out with some nice neat factors. If I'm just being honest. 2, you see a 2 and a 4, you pick the problem because it's like, that's not it though. That's just the 1 over 0 case. We have to do the negative square root case. Yeah.
Whenever you read the formula at the very beginning,
Oh no. Yes.
how does it flip the signs? Did you like multiply it by -1?
Could do that. That flips the signs. Because 0 times -1 is 1. Or you could just plus them all over to the other side. Plus, plus, plus. You could do either of those two things. You can do multiply by -1. Totally cool if that's the way you do it. Because then you multiply this side by -1 and it stays 0, right? Or you could go plus x squared, plus x squared, plus 2x, plus 2x, minus 4, minus 4. These all cancel. So you're still left with a 0 and our new formula. Either way work. I don't think one's better or worse than the other. Actually, I do. You were right. -1 is better. This sucks. What's up? Well, wait, we're not done. No. We need to check for square root can't be negative. Right? The square root can't be negative. And how do we know where this thing would be a negative? You could plug in two numbers, or I'll give you the easier way. You could look at what shape that is.
Wait,
Which way does it face? Upward facing parabola. So what does that mean? The two roots, where is it negative? Between the two roots or on the sides of the two roots? If it's an upward facing parabola, where is it negative? Right there, right? Between the two roots are negative. Because root means x-intercept, right? And this is an upward facing parabola. So between those two roots, we've got all negative numbers. If it were downward facing, it'd be flip-flopped. So that means none of those numbers get to be in the domain. So that means our domain is negative infinity all the way to 1 minus root 5, union, 1 plus root 5, infinity. And do we need to worry about the log? No, we do not.
Wait, why did you do a plus in front of the 2 on the quadratic formula?
Because it was negative, negative. Negative b plus or minus the square root.
Yeah,
Wait!
plus 2.
You guys,
That's what I was so confused about.
who talked me out of that?
Because you divided by the -1.
Well, it does not have to be negative. Oh, wait.
You guys.
Well, I mean,
I just trusted you. My whole world. Does that change very much?
Just what?
No, not at all.
No, it doesn't. It just changes
The up.
all of those signs to negative, 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 negative. Changes it to -1 right there. Which might flip around. Nope, it still stays in that order.
But question,
What's up?
you do realize the B term would have been negative, right?
But you divided it by -1.
No, I did the quadratic formula with this problem right here. This was just my steps to get to that problem.
So you divide by -1 with that.
What?
No, I'm asking where you're.
Oh, how did I get that?
Yeah.
Yeah, divide by -1. Or times by -1. Or move them all over using addition and subtraction. You'll get to the same situation.
But if I move over, I don't have a.
What?
I have x squared
But you say it's supposed to be plus?
What's up?
For the 2, if I move it over by like plus to the 0, like move to the 0 side, I'm gonna have
Negative.
plus 2.
Yeah, we have plus 2x right here.
Oh, I thought you changed it.
What is that? Where did you get that? Which one?
Question, Professor.
What? Sorry.
Wait,
What are you talking about?
Number 18? When did we get the 5 over 3?
Number 18.
The one that you ln 5 over 3?
20 over 12.
Oh.
Or actually 20,000 over 12,000.
that'll be like 12.
Hmm?
12.
Number 12? Oh, yeah, that was a typo. Just scratch that one.
There was one typo.
That was it. It was that one.
Oh,
Number
yes, it
12?
was that one.
Great.
How's that
Um,
typo?
I don't know. I don't even know what it's actually asking.
It says A equals 3.
It might have been supposed to say like log of A equals 3 or something like that. I mean, heck, if it was log of A equals 3, we could do that real quick. Log of A equals 3. How do you write that in exponential form? Maybe that was a typo. 10 it. Goes away. 10 it. Now you've got A equals 10 to the 3. Cool. I don't remember the exact problem, but there's the thought behind it, I think.
Mr. Cohen.
Yes.
Tenant. 9.
Which one?
Tenant.
10A. Find the domain. Okay, this one's thankfully a lot prettier and nicer because we don't have to do all that quadratic formula stuff. What is the restriction that ln imposes on a domain? This red stuff better be what?
Positive.
It better be positive, not even 0. It's got to be bigger than 0, right?
Say greater than
So
0.
2t minus 3 is bigger than 0. Solve for t. You're done. 2t is greater than 3. T better be bigger than 3/2. In domain speak, that is 3/2, comma, infinity. That just comes from knowing that the... Oh, I guarantee you, too. Here, there's another typo. I guarantee you that was supposed to say ln right there.
Okay, so it's
Otherwise, it's just oral numbers, which is cool, too. Whew. All right. Pause this and take a second to talk about calculators and all that